All right, welcome to Nested Loops. We're gonna pick up with chapter 10. Diego will finish that, and then we'll switch to 11, and I guess 12 with Brett, and we'll see how that goes. So I'm gonna transfer over to Diego now.
All right, can you hear me?
Yeah.
All right, this is gonna be super quick. The hold on, let me close the door behind me. Sorry, I had an echo behind me. So last time we talked a little bit about like the CES event where in 2010 was a car company that said got the best innovator honor mention or prize, and actually it was like this car is so smart you can use your smartphone to pop the trunk, which is in fact like very dumb. What we talked about a little bit. That is much better. Like Ford Escape later on came with a different idea. How about we just put some sensor on the bumper, can read the foot kick, the way you don't have to, if you have your hands full once you get to the car, put everything down, pull up your smartphone, um, you know, press some buttons, find the app, press some buttons, and all that kind of stuff. You just want that to pop the trunk, and the sensor under the car is much simpler. And this happens quite often. Like we talked about like the Tesla car has got like this like a gigantic screen that is much a distraction, and later on, like the author talks about going in Australia, and I saw an advertisement for Nissan Leaf that talks, what if your phone could make your car cooler? And because in Australia there's it gets very hot, and the typical study was like, okay, you go to the movies, and you want to have your car cool down by the time you get there. And the typical use for that would be 50 minutes before the movie is over. First of all, you need to know the movie is about 50 minutes to the end. You pull up your phone, you get berated by everybody around you. You find the icon, you click, your car, you turn on the cooling system. Then eventually, once you get to the car, it's nice and cool. Later, Mazda came out and solution, much simpler solution. Instead of going with a smartphone app for the 929 car, they installed a thermometer and some solar panel. And what the thermometer did is it sensed the car getting too hot or getting really hot, and we'll have fans and powered by solar panels that will help cool down the car. But again, like it would not cool down the car a lot. It will cool down a little bit, and in general, you will save more money. Will save some gas because it will take less time to cool down the car. Also, the solar panel, when in the winter month, we're charging the battery in the car. This is nice and dandy, but still, bringing the temperature from 167 to 140 doesn't quite solve the problem. The car is still very hot. And Prius came, and add a little addition to it. Pretty much, the Prius that had moonroof, you could open the moonroof and have the fan and have everything powered by also solar panel on the roof. This solar panel did not charge the battery in the winter months, but did help a lot. Did a lot better at lowering the temperature. So even though it's like not really cool car, it's not like it's gonna be 70 degrees in the car. It would be near ambient temperature. So if outside is 90 degrees, your inside of your car will be like a little bit above that, maybe 100 degrees. Again, 40 degrees better than the Mazda solution. And pretty much like, the chapter concludes with kind of an imploration to try to come up with smarter solution and not, better screen or screens that have the latest nifty special effects like parallax or stuff like that. And that's the end of it. So off to Brett.
Any discussion on that as far as ideas or thoughts? Okay, we're going to Brett then.
Cool. Right.
Okay, can you see this?
I can. Who serves who?
All right. The title of the chapter is actually something like Computer Tantrums. Please set your password to 9,000 characters and don't use your last 6,000 passwords. Okay. Who serves who, computers or people? First, I want to say part of the chapter is about technological and what I call societal growth, probably a better word for that. And have this quote: the technology industry has not only been able to make huge improvements in the past few decades, it has also been capturing a growing amount of educational mindshare, thereby producing an even stronger, deeper thinking overall tech workforce. In 2012, Stanford, sorry, I put Stanford because we work in Stanford. Computer science is the most popular undergrad. In 2014, other undergrad programs were starting to feel left out, I guess. So they started to offer intro CS classes, more to like humanities and other programs. And in the last couple decades, I guess, more art and design schools are offering interactive design programs. So not only is there more for programming, there's more for designing around interfaces and stuff like that. So in general, there's been a lot of growth, both with the power of our computer and the amount that society has wanted to use computers. There's this example. I know nothing about chess. I imagine these are a bunch of chess moves. I guess it's art to some people. But there's this supercomputer that in 1997, Garry Kasparov was the world champion at chess, lost to IBM's supercomputer Deep Blue. IBM offered Garry $700,000 to beat Deep Blue. Deep Blue relied on 510 of the best processors of the day. I put this somewhere else, but it could calculate 100 million to 330 million moves within a second. Turns out that the actual last fatal blow where Deep Blue won was kind of a glitch. Deep Blue didn't necessarily have the confidence or the knowledge or insight into making the final move, but based on probability or whatnot, ended up just choosing a random path and chose the right one. So it was said that even the computer programmers of IBM were kind of in shock about how quickly it did it, I guess. And that kind of sparked a moment where, up until that point, people knew that computers, were good for a assortment of other things like cranes lifting concrete to build skyscrapers, trains speeding over tracks. We knew as a society that computers were good at simple tasks and better than us. And I'm sure, although computer scientists understood the power of analytics that computers could process, the general population didn't necessarily appreciate how powerful computers were until this moment when the IBM Deep Blue computer beat Gary at chess. So basically, it's a moment where we realized that they could outthink us strategically. And this was something new to society. Of course, the computer scientists probably not. So yeah, Deep Blue could process 100 to 330 million potential moves per second. I just want to note that computers of today are much more powerful than Deep Blue. Even our worst laptop, I guess, that we have laying around our house from 10 years ago is many, many times more powerful than Deep Blue. So the conversation goes into, what are we doing with these machines? A lot of complaining. We're using forms. We're asking for specific formats for things like dates. When you try to go on a flight, you can only type in, DD, MM, YY. Asking for passwords, yelling at the users, no, you've gotten all wrong. So basically a general complaint over the fact that we don't use machines as well as we could, especially for how powerful they are. So we serve computers is the conclusion. We are forced to navigate complex databases to obtain simple information. We are required to memorize countless passwords with rules like 1 capital letter, 2 numbers, and a punctuation mark. Spew out random facts for an algorithm like our childhood best friend. Most importantly, we're constantly pulled away from the stuff we actually want to be doing. So we serve computers. Chapter, and the author says, let's reverse it. Let's have computers serve us. Let's take advantage of the power of computers. Let's fulfill the hopes and dreams of today's people. This means reversing the paradigm and finding ways to avoid form fields and fit computers more into our lives. Along reading this entire chapter, I think this is a great book with the timing of it coming out, 6 years ago, and just seeing all the advances that have been made, even since the book was written, is actually really phenomenal from my perspective. One example I have is I often forget the password to my bank, and I really don't care about that password. I don't write it down or anything. So every time I want to get in my bank, it seems like I have to call them to reset the password. And I often can't find the account number or whatever it is, so I'll call them and they have to go through the whole series of 65 questions to verify my identity, which I appreciate and it makes sense, down to the point where they use public information to check the last 3 addresses. We've probably all seen this. There's a series of 3 or 4 types of questions that they can ask on basic information, in addition to other information that we've provided. Now, with Chase, they've offered voice recognition, which I have actually opted into, not sure if I should, for AI. So now, and they don't even tell you, when I call, they'll ask me to say my full address out loud. And I've recognized that must be their cue. They must queue up the voice recognition algorithm against the way that I've previously said my address or something like this, because now they ask me for no verification information. I'm calling from my phone number, mixed with me providing my address, mixed with the algorithms and the machine learning for voice recognition. They don't even say we're about to process your voice and figure all this. They've made it like that unintrusive and that unscary to the normal basic user who might be like, wow, you're using my voice. Of course, fingerprint scanners on phones, not that secure and all that, but it's an improvement in a way. Facial recognition, same deal. So I think when this book was written, that stuff was not commonplace, and now it's in all of our latest generation phones. that is actually the end of that chapter. So I would like to open that up for discussion. Anyone have any similar thoughts or any conclusions or any questions about Deep Blue or?
No. I mean, I think that's the computer beating a human. If you're not that much in a chess, I mean, for ages they just thought that couldn't be solved, right? And and recently, Alpha Zero a few years ago taught itself chess over 4 hours and then beat a champion. It used to be so hard to
And
beat.
now Go is even more remarkable.
Yeah. So that was significant. What I like about his chapter is he basically says the same stuff as Matt's as far as computers. Like, look, for years we've served, programming languages have served the computer. Let's make a programming language that makes the programmer happy. So obviously, and I think when we compare, a lot of times, it's something for the Ruby users. Like, yeah, that's kind of was Ruby's approach for people. Let's serve the people. That's and then you think, and that gets continued in Rails. If you think of some of the stuff like active support got 5 days from now kind of things, where in the same idea, what's the right interface? Time.now is great, 2 weeks from now, 4 weeks ago. Like, that's how we talk. That's the interface, and it fits in well with Krishna talking about, hey, what is the actual interface that you're doing? But this chapter is more about how can we use the smarts, or not the smarts, all the power. Computers are tough enough now that we can beat Go masters, which was before unheard of, and then we're still making these impossible to remember passwords. Which again serves the computer. We'll also make it really hard, though things like that. So it is. I think it's similar to the other chapters where, like in the very beginning, we're talking about, hey, I've got pop-ups and dialog boxes and sliders, and so then if that's my tool, then every problem is a nail. So we think of everything screen. That was the chapter. The chapter was like, oh, we've got screens, so let's solve everything in screens. I want to get into my car, so I'll give them screens. Go, no, why don't you do a proximity sensor? Or like Diego was talking about the trunk thing. I want to open my trunk. I got a bunch of stuff in my arms. Well, what do I got? I got screens. Go, no, sense my foot and open, proximity. So I think the emphasis chapter is more, look at all the horsepower we have. Why are we still making you do form? And stuff that's really hard for the human and probably only marginally better at helping the computer.
Yeah, I have a couple problems with the chapter 2, which are like, everything costs money. So of course, if developers could work for free and you had a million of them, yeah, we'd make things easier. The other thing is, I understand that he's kind of has like a larger viewpoint of all these problems, and the book makes sense in the sense that he's opening our minds to certain concepts, but at the same time, if you need to ask for certain information, I don't want to say this because it will be wrong in 100 years, but you have to ask some information. like I don't know. I guess I'm trying to say you can't get away from forms with certain applications. So
right.
I like to see how you could, but
it's
yeah. Of course, that
like what you were saying, all the stuff that's happened since the book is written. I think we're good at, when we see a good idea, we're good at copying it, and sometimes improving it. Like, I think phone tech is like a lot of like Apple's latest sexy is something Android did like 7 years ago, but Apple picked it up, and in some cases they do a slightly better version. So once we see something, like now that one guy came up with the proximity sensor for the cars, other people, once they go, oh, that is better than 15 screens. So I feel he's trying to expand your brain, again, with the whole, all you got are screens, so we make everything as screens. Like, thinking a little deeper in the problem of, well, let's think about, I know I have screens, but let's think about how this would be convenient. It's kind of like, I think a trait that would be good for a UX designer is someone who's very impatient. Oh my God, I gotta do 15 screens. I'm gonna lose my mind. Well, I gotta do 3 screens. I'm gonna lose my mind. If I can't do it in 2 swipes, I'm done. And so the one who's impatient and then figures out an intuitive way to do 2 swipes. Like I kind of feel that's the problem with like Apple. Apple and the one mouse. Back in the day when there weren't a lot of options, one mouse. Why give me 3 buttons? And you see gaming mouses with like 26 controllers. It's tough. But now, because we only have one mouse, you got 3 fingers, you got 4 fingers, you got circles, you got swiping. It's like I can't remember all these combinations that are forced onto me because I have one mouse button. It's like
Yeah, and of course, Elon Musk, he says, we have like a communication problem. Of course, Elon's crazy, but he says, we have a communication problem with the computers right now. The computers are very quick, but how we communicate is through our fingers kind of thing. So, of course, forms could also be phased out if we all start to get chips in our brain, which we could think, and then forms could in essence be filled out based on our thoughts, but I wouldn't opt into that anyway. So yeah, okay.
Well, kind of like back to the horsepower thing. Voice recognition, when Alexa works, it's great. But when she's not working, it's me cursing, and I gotta wonder what the people at Amazon listening to me throw all kinds of 4-letter words at Alexa for not understanding what I'm trying to tell him or she is.
Yeah.
It's like when it works, it's magical, but when I'm flinging 15 minutes of curse words and then giving up and walking over to my device, that's when it fails.
Right. All right. Next chapter, machine input, also known as signals. Talks about our senses, our powerful senses, the complex and instantaneous seeing, hearing, tasting, and so on, and taken for granted as the obvious and transparent ways for us to gather information. Rotten meat stinks, sandpaper feels rough. How do we talk with computers, though? User input. But when it comes to computers, we build on a different information gathering system. And this information gathering system is what fuels half of our bizarre relationship with them. We rely on user input. The joys of user input. You know what? Fuck drop downs. It's in the book. It's a quote. Our powerful machine should sense the world more like we do. The technology exists and it is prevalent. Remains mostly unused, and computers should serve us to make our lives better. Chapter goes into virtual reality. I didn't really see how it was tied to the chapter. I guess it's tied, but I kind of glossed over it. By 1990s, a growing number of computer geeks saw virtual reality as the future. Sure, maybe it would become a world where people were so addicted to the virtual that the real potential conversations with other people in real life would cause panic and stress, but that might not have been all that different from the world those geeks already lived in anyway. Basically talks about how virtual reality, I guess, is a form of this. I kind of glossed over that section. So let's go to Xerox PARC. Xerox PARC, there's a lot of people over there. They, I guess, were the labs that created the first graphical user interface. But in the early 90s, they were already trying to figure out the next wave of computing. They started experimenting with ideas to create invisible interfaces at the time before most people have even heard of the internet or even known the word email. So people have been thinking about this problem with interfaces for a very long time. The people at Xerox PARC were a big group of that. They looked at how computers went from shared to individual and got smaller because they were looking at how mega computers at the time were rented in a room. Saw that more and more people were eventually having more devices. They noticed that there's a lot of complex jargon in the way that we deal with computers. So most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they are undistinguishable from it. He's referencing a book that or an essay that was written in 91. More than 50 million personal computers have been sold, and the computer nonetheless remains largely in a world of its own. It is approachable only through complex jargon that has nothing to do with the tasks for which people use computers. Which kind of makes sense because if you're trying to send a bunch of emails to a lot of people, you need someone that knows how to use like matching and all this other stuff. So it's not like that quick. Part of the reason why we have careers or whatever is because we've learned this jargon. So an example of us improving the world is something that Xerox Park did, which is Active Badge, which is an experiment of a 55 by 55 by 7 millimeter device. It weighed 40 grams. It had no screen. It broadcasted the idea of who was wearing it via infrared and acted like a beacon. Receivers that were installed throughout the building automatically and continuously processed the infrared signals. And using this badge, which some collaborators had in groups of up to 200 people in one building, they had experiments for allowing doors to automatically open, like being unlocked based on your badge and who you are. Computer displays to boot up with personalized settings, reroute calls on landlines via location. So to help receptionists, if I was over at one of my other coworkers' desks across the building based on the badge, one of the experiments was the receptionist could just send the call directly to the phone that was near me. I'm sure there's a lot of technologies like this, and everywhere down the line when I read this, I think of the bad security implications, but I guess there's always ways around that. And it is only an experiment to show some things. So, but I could grab your infrared. I could steal what infrared you send. So these receivers were sensors, kind of like our nose. They received one kind of information. Of course, they could probably receive many. They didn't rely on user input. It was just based on this beacon that the person wore. And they use automatic sensory signal-based machine input. He goes into how he likes the word machine input, but if you're talking to like an electrical engineer, you should probably use the word signal. The computer, or basically whatever it was that processed this, the computer understood what the data signals meant through code written for what's called data signal processing, kind of like your brain interprets smell. And then computer software on top of that acted upon this information with an algorithm, kind of like you decide to eat something because it smells good, or you decide not to eat something because it smells bad. So yeah, I thought this was a really cool experiment. It makes sense. No screen, great example.
Mm-hmm.
Change the conversation, please. Let's change our conversation with computers. I often feel like this book is kind of like a rant. Let's empower computers to observe the world.
He says that like in the first chapter. This is a rant, but it's not an aimless rant.
Yeah, that's true. Let's empower computers to observe the world beyond form fields. Let's give them the ability to sense our needs with sensors and other signals. Let's replace tedious user input with instantaneous and painless machine input, where the computer system finds the information it needs on its own, whenever and wherever possible. All right. Let's fix our pain. We're all in offices. Some of these offices are windowless. We have our computer screens, they're glowing. There's the quote. By pushing computers into the background, embodied virtuality will make individuals more aware of the people on the other ends of the computer links. This development may reverse the unhealthy centripetal forces that conventional personal computers have introduced into the life and the workplace. Even today, people holed up in windowless offices before glowing computer screens may not see their fellows for the better part of each day. So sad. Let's fix our pain. We should all be outside in the sunshine. Kind of like Dana Point now. All right. Examples of machine input. Headlamp. There's this example of cave divers. And anyone butt in if you want to say anything. There's actually like a group of cave diver rescue people. This book was written before the Thailand children getting stuck in the I think it was in Thailand, the actual cave, which actually captivated me. I think I followed it like every minute, sending Katie texts like, "Oh my God, they saved the kids." That was such a crazy story to me personally. I don't know why the news really got me there, but it was written before that. But he explains how, there's teams of people that actually will globally help people that get stuck in caves, depending on how bad it is, I guess. And one example of something that used machine input versus user input is a headlamp, which had a light sensor with a microchip that would automatically and instantly adjust light intensity. Because using the cave an example, if you wanted to look down the cave, granted there's no water, you could see far down the cave and then look down at a map right away and not get blinded because the map is so close. So I thought that was a really cool example. GPS could of course help calculate contextually appropriate actions. A lot of apps know when I'm driving. Spotify I use, and the input becomes a lot bigger. I know we've discussed that previously in this. Bluetooth radios can talk to each other. Cameras can provide color information for things like reading traffic lights. Obviously, since writing this book, more and more cars have gotten self-driving things. And part of the reason why I'm even considering getting a new car is because the ability for cars to stop themselves if it's in imminent danger. The other example is Junior Seya.
I don't know. It depends on what the origin of that name is. If it's French, it's maybe Sue. So I don't know.
So this guy was a football player, wonderful man. He got an award by George W. Bush for being a great citizen. He helped serve meals to children couldn't afford them, and basically was just an amazing guy. And many years later, and I guess he was actually known in Oceanside, in that area, San Diego. He was just a wonderful person overall. But many years later, he committed suicide, unfortunately, and in an autopsy, they discovered that he had CTE. And I'm sure many of us have heard of it. It's believed to be caused by repetitive head trauma. In his case, it was many hits he endured while playing football. Some symptoms are memory loss, confusion, impaired judgment, impulse control problems, aggression, depression, and eventually progressive dementia. So it's believed that he went from his, I guess, just bright and bright personality to eventual depression. Sadly, his case appears to be part of a larger pattern. A lot of information has come out on this ever since this book was written, for anyone paying attention to the whole problem, I guess. But 33 of 34 brains of deceased NFL players studied at Boston University showed signs of CTE. After a few years of testing, the league has even admitted in federal court it expects nearly a third of retired players to develop long-term cognitive problems, and that the conditions are likely to emerge at notably younger ages. I really just don't even like this chapter. So I actually know someone I went to high school with that actually was an NFL player. He played for 2 years, and he left. He played for Washington. I don't know anything about football. But he left. He left $400,000 on the table with his contract. He left mid-season because he decided it wasn't worth the money. So there are a couple football players that have even just left. So, Reebok Check Light. I want to note real quick right here that the CDC did make an app, a simple app, kind of funny GUI with this app. But nonetheless, it was actually a great app to have, which would let people get information on, how to wear a helmet correctly, sizes of helmet, I guess, how to see signs and symptoms of head trauma, so you can help your children and stuff like this. And great app, but of course you have to download it and then have to know how to navigate the app and figure this out. And the information probably ultimately just says go see a doctor. But MC10, working with Reebok, created this skull cap, which relied on signals through machine input and a network of sensors to help detect brain trauma, and accelerometer or a gyroscope, probably a bunch of other stuff. And basically, it would display 3 types of lights on the back of your helmet. Green blinking light meant that everything was good and that it was functional. Yellow light meant that there could be some problems, and red is trying to indicate that there's been some serious head trauma. Of course, it doesn't tell you everything, but it's an additional sign or a way of realizing how bad it's been. And it's much better than the CDC app because you don't have to even recognize the signs yourself and then go into this app and see that and verify that you recognize the signs more, I guess. Of course, not perfect, but I think it's great. And I don't follow what the NFL is doing with helmets, but I know it's a whole thing. Forget the interface. Let the possibilities pour. He's basically saying we're so focused on the interface, we don't even think about the solutions we could come up with. By pushing the interface and the screens out of our mind, we may actually even come to the realization of more life-helping, life-saving technologies. So this head skull cap is an example of a kind of cool tool where we can focus on and forget the interface. Sorry, we can focus on this type of tool and forget the interface. When we stop thinking about which screens can do what and instead focus on solving a problem with as little interactions as possible, and when we solve a customer pain point in a way that actually utilizes the power of the immense progress we've made in computing, well, that's tech worth celebrating. Which I do think, I don't know if there's new technologies with the green light, yellow light, red light. That's awesome. That is worth celebrating. There's probably many examples of stuff like that. And I think the cars stopping themselves when they get too close. I know I'm kind of paranoid, but I personally do not use cruise control in fear that I don't trust the human body. God forbid anything happen. Wouldn't want to go into a car at 75 miles an hour. The new cruise controls have distance sensors. So if you have cruise control and you're coming up on a car, it will keep a certain distance depending on what you've programmed. If you were to fall asleep, whether you had cruise control or not, the car has the ability to stop itself. I think this is great for society. Maybe not someone my age, and but as we get more and more health problems or whatever, this is great. So sensors are one way to provide richer information for machines. They can seamlessly enable a machine to read the needs of the outside world without a submit button. Kind of like we hit the brake. And there are many ways to gather the signals that lead to machine input. These are just quotes. When we think in a different way, we begin to invert the prevalent computing paradigm of modern day consumer software. Unseen opportunities to solve problems more elegantly and usefully become part of our design process. And last page, that is last page. I just had some quotes that I thought were good. So that concludes the chapter. Any
Yeah, so this reminded me. So for my mom, we got We got one of those devices, the help I've fallen, I can't get up kind of device.
Right.
And it's this thing that you wear, and it's got some kind of motion sensor, so it can tell if you fall. So if let's say you fall and you're knocked out, well, you're not pressing any button, talking to anybody. So
Right.
so it has some kind of like impact sensor or motion sensor. So I guess if you fall at a certain rate, it can tell, and then they can contact you. And I thought, oh, that's clever. And the point of this is if someone's, I think still at this point, someone my mom's age is not super tech savvy. So you can imagine, well, just pull your smartphone out. You've fallen down. Find your app. Click. What kind of injury was it? Is it strong? It's like all this stuff. So it's good. So you can fall. And I don't know exactly what the policy is, but I know they have ones with detection. Oh, you fell, and maybe they call you, and I guess if they can't get you, they send the cops over or whatever.
Right.
Or if you fell down, you say, oh no, I'm fine, or I just dropped my thing or whatever. But I thought that was cool. So here's a case where you're targeting a certain demographic. I guess the elderly who are, even if they're tech savvy, they're not super mobile anymore. And which reminded me, a friend of mine, she's working for some company, and the product they're trying to come up with is a tablet for old people, which is a similar. The problem I think is, unfortunately, is they're just trying to figure out what better screens to do. But general is like grandma, like my mom in particular, she doesn't want a smartphone because she can't remember how to work anything besides the phone part.
Seems like it wouldn't be profitable because everyone knows how to use computers, and eventually everyone's going to know how to use computers. But
Right. So they're trying to come up with something. So they're trying to address this, which the help I've fallen. It's like they're targeting old people because they know they're less savvy. And I think I saw some of the screens where like here, it's one window with 3 buttons kind of thing. So they're trying harder, but I think it's still mostly screen based. But I think for them, they're trying to figure out like what are the 4 things that they wish they could do, but they're afraid to grab an iPhone, and tiny little icons and stuff, and Uber, and God forbid they try Snapchat, which changes its interface all the time. Kind of things like that one. So, but so in the case of if you're targeting, it's almost like you should say, you know what? Let's just assume people are tech impaired. If you started with that as your base assumptions, you might come up with better interfaces than, oh, I'll just assume this guy is a whiz with his thing, and he can text 2 phones separately with left and right at the same time, kind of thing, which is not that apparently different than my kids would run 3 devices at one time, kind of thing. But
Right.
but I think it's put yourself in the mindset. If you're going to start with, look, I got 15 widgets, where do I start? So, oh, that's the wrong place to start altogether. What's the problem? And our screens and your widgets even appropriate for the issue? And then I guess in this case, this chapter is more about a machine input. How can we help them with detection? I think RFID, IoT. I don't think IoT was that big. The IoT hasn't met its potential yet. I haven't seen anything
Right.
really. I think there's great potential once people figure out what to do. I think the closest to thing that is still pretty much like home automation, Alexa, Google Home thing. That's as good as we've gotten so far. I'm reminded of something. Was I reminded? Oh, the opposite. I think the opposite of this is, you ever get one of those things where you call and you want to talk to a person, and it literally won't let you do it if you don't go like 4 menus deep,
Right.
and it's all questions. Like you pick up, I get this. What are you calling about? And of course, you don't know, so you throw some words, and if you pick the chosen 11 words, it gives you an answer. And if you haven't, you keep trying to figure out, oh, I want this. Well, if you want this, say this. You want it. I don't want those. I want this. And you say, then I say like representative, which works sometimes, but no, it doesn't.
Sometimes you can just hit 0 over and over and over.
And it
I've
won't.
heard-
No, tell us what you want so we can guide you. So I've been trying, but you won't let me. Representative. So then you lie. Okay, I'm here for checking account.
Right.
No, it's not what I'm here for. But if you can get me to the page where I can get representative, so now I have to figure out how to navigate by lying to the point where I can ask for representative.
Been there.
Oh. So the curse words fly. Unfortunately, I have selectively thrown my phone onto the bed to not break it because I was mad enough to throw the phone, but smart enough not to throw it at the wall. So I would say the opposite. The opposite is currently happening in phone service, where we've eliminated the representative thing, unless you go 3 menus deep. But unfortunately,
another example, I guess it's a little different maybe, but like the Nest smoke alarms, Nest carbon monoxide alarms, usually you have to test yourself. So like old school or just normal fire alarms, you have to go along.
Mm-hmm.
I'm sure most people don't do it, but every 6 months, click a button and see if it beeps back.
Yeah.
But the Nest one will just test itself. I always thought it was kind of silly, and originally I didn't understand how those tests work with smoke alarms because it's like, okay, I'm clicking it, it's beeping. Is that just telling me that the speaker works?
Mm-hmm.
So there's certain things like that technology are making, easier and more reliable because we'll forget to do it.
Yeah, cool. I think, and this is related to input and sensors, auto detection of things that, and then giving you alerts. That's kind of a little bit of like the red, green, yellow thing for the helmet. Auto detect and give you alerts. Kind of like what we're trying to do with Nagios, and let us get us alerts on these things where you set thresholds, where you have sensors. You have input. You should be able to have some thresholds to tell people your oil is low. Like we've done that. And that's gotten better. Your car door is open. Your tire pressure is low. That's something that's kind of cool. That's something I would like in a new car.
Yeah.
You're too close to the guy in front of you. That's good. I kind of like how, like, Diego's dashboard reads the speed limit signs. So actually, I've noticed now Google knows the speed limit.
Yeah.
It also knows that I'm over the speed limit sometimes.
I mean, even the Garmin, I think it was Garmin, original GPSs, previous to being connected to the internet, like a smartphone.
Yeah.
If you had a good one, they would know the speed limit based on data that it had.
That's
with the
cool.
maps.
I as far as I can tell, like Diego's car has a little sensor that just reads the sign. Is that true?
Right, probably, yeah.
I think that's cool.
Yeah, the BMWs will read the actual speed limit signs and compare them against the database that they have.
Yeah, so
I think both Honda and what's the
Subaru, yeah.
Have like a speed reading, speed limit sign reading. Right, they both do it.
But it adjusts your speed.
Huh?
It auto adjusts your speed.
No, it doesn't adjust, but
it just flashes it.
Yeah, flashes.
Okay.
It pops out on your screen
dash.
like right now you're in this thing,
Okay.
and it is kind of funny because like apparently it sees it, and once you pass the sign, it pops it up. Like it's not before you press the sign. As soon about a second after you press the sign, it pops it on your screen.
Yes, it just takes a while to show up.
Right. No, I think because it's like you're not in that zone yet, and then you are in the zone.
Right. That too.
The other thing that like you were talking about, like stuff like auto collision. It does have auto collision. It does have follow through. So you said it like you use cruise control, and then you said what distance from the car in front of you want to be.
Oh, all right.
So if your car slows down, your car slows down.
I've rented a couple cars with that. I thought it was awesome.
Oh, super.
What? Say again?
I've rented a couple cars with that. I thought it was incredible, and it's becoming more, like not standard, but like
available.
More and more companies are releasing
It's more
it.
available. If you can afford the feature, you should get it.
Well,
Right,
Tesla is fully automatic, so other cars should have like at least that.
Right.
At least with the Subaru, I can say there's a few bugs with the lane changing. Another thing is that lane changing, it can tell you that you're changing lane, but also can adjust to backing, which you're backing the lane. So if you like change a lane without the
Well, signal.
yes, thank you, turn signal, you'll feel a force that could put you back into your lane, right? But if you push harder, you eventually go. And I had both when it was like a light rain in a couple places. The road was like a mirror, and it was reading the reflection of some signs on the right side as lanes going to the right. So those two like stripes of white were like much brighter than the street. So it jerked me to the
Oh
right.
my god.
So
Yeah, I don't think I would use that feature that much yet.
yeah. So when the street is like that, I turn it off. But the collision detection is kind of funny. Like lately, I think it happened 3 times so far. That it tells me I'm about to hit something when there's nothing in front of me. There are some bugs every once in a while, and it all happened in the last month. I'm trying to figure out what trips it. Because
Yeah.
like, it kind of freaks you out. Plus, the collision detection actually can trigger the brakes.
Right. That
So I don't want to be driving around and somebody is behind me and the car just comes to a halt.
Yeah. Scary. Hey.
Keeps you from colliding. Doesn't keep him from colliding. All right.
Yeah, I'm thinking about mentioning it to the car dealership, like as a bug, because the collision detection going off like that, it is kind of dangerous.
All right, cool. Any other discussion, question, comments? So chapter is what, 13 is still part of principle 2, leverage computers instead of
Aww.
this. So there's one more for that, and I'm looking forward. Principle 3 is 2 chapters. Do we want to shoot 13 and then 14 and 15? I don't know if Brett wants to continue that because he did the principle, or
I could do 13.
all right, let's do 13. Let's assign 14, 15. Who wants to go unless they want to be voluntold? Too bad we can't volunteer Scott.
Then was it? Want to Sam? No, Don.
Okay, I'll do it.
Or Andrew. When was Andrew the last time?
I don't know. All right, Don, acknowledge. We'll see Don. We'll see Don's wonderful notes.
Yeah, that's fine. I'll do this.
All right.
14 and 15, you said?
Yeah. So Brett will pick up 13. We'll do 14, 15 next time. And the time is good. We're like only 2 minutes in the hour. So, all right. Well, thanks for coming to Nested Loop. Enjoy your time. I'll see you guys in 2 weeks.
Yeah.
Yeah, thanks, guys.
Yep. Thanks.